Okay, now we're going to look at what I call non-trivial trigonometry problems. Most of the problems we've done so far have been relatively simple. They've only required one or two steps. The problems in this section will require some more thought and will usually take more steps to solve. Now, as before, diagrams are key. They can help you visualize a problem. So whenever it's appropriate, draw a diagram if one hasn't been given for you. Let's look at our first example. This one deals with adding multiple displacements, and there's a diagram there, or at least part of it. We're going to mark up the diagram as we go. But here's the problem. Suppose you hike 3.1 kilometers on a heading of 45 degrees. Now remember, if we map out north, south, east, and west, headings, navigational headings, are measured clockwise from north. So a heading of 45 degrees means that far, so this way. Northeast, basically. That's this first vector drawn right there. That's a heading of 45 degrees. So the problem says, suppose you hike 3.1 kilometers on a heading of 45 degrees. That gets you from here to here. Then you hike 2.2 kilometers on a heading of 125 degrees. So from this point, you hike in this direction, and that's a heading of 125. If you were to draw a little north, south, east, west right here, 125 degrees would be that far around, so that direction. So the second leg of your trip gets you from here to here. And then you hike 4.3 kilometers on a heading of 52 degrees, and that gets you from here all the way out to the end here. How far did you end up from your starting point? So what we're trying to find is the distance from the very beginning all the way to there. That straight line distance, that's what we're looking for. Okay, and here's how we're going to do it. We're going to take each of these vectors, each of these arrows here, which we call vectors, and I'm going to give them names. I'll call them displacement 1, displacement 2, and displacement 3. So this first one is displacement 1, so I'll just write D1 here, and the next one is D2, and the next one is D3. And then I'm going to find the east and west components of each of those. Or you could think of them as the x and y components. So, and I'll draw these in. For the first one, I'm going to draw the x component going to the right and the y component going up. And let's label those. Let me try to draw that a little better. Okay, so this is d1x right here, and this is d1y. Okay, and then for d2, d2 goes a certain distance to the right. How far d2 goes to the right, that's d2x. And then how far it goes vertically, in this case down, that's d2y. And then d3 goes a certain distance to the right, that's d3x. And a certain distance up vertically, that's d3y. We're going to find each of those. In each case, we have little right triangles formed. And so we can use our basic right triangle trigonometry to find these distances. So let's think about this angle right here. If this was a heading from north here, rotating in that direction, if this was a heading of 45 degrees, then this angle right here has to be 45. So let's write that in, 45 degrees. And then let's find d1x and d1y. What you should see is that d1x is going to be d1 times the cosine of 45 degrees. So d1 we were given is 3.1. So d1x is 3.1 times the cosine of 45 degrees. And you can work this if you're writing on the page. You can write all this now down below the diagram, but I'm going to switch over to a fresh page here just so I have room to write, and I'm going to write d1x is equal to 3.1 times the cosine of 45 degrees. And take out the calculator and do that calculation, and it comes out to 2.19. And this would be in kilometers because the 3.1 there was 3.1 kilometers. And then d1y, the y component here, is going to be d1 times the sine of the 45 degree angle. So back over here, I'll write d1y is 3.1 times the sine of 45 degrees. And you should realize that the cosine of 45 and the sine of 45 are the same. So both of these come out to 2.1 kilometers. Or you can just punch that in on the calculator and you get that. So that's d1x and d1y. Now back to the picture, we'll do the same thing with d2. But we need to know this angle for d2. So let's think, remember, if we have our north, south, east, and west, we were told that this was 2.2 kilometers on a heading of 125 degrees. So the length here is 2.2, and the heading here is 125. So from here around to there is 125 degrees of rotation. So this is 90. So to get a total of 125, that has to be 35. So if we look at this triangle right here, this angle is 35 degrees. So let's write that in. It's a heading of 125, but that angle right there is 35 degrees. So d2x here will be d2 times the cosine of that angle, and d2y will be d2 times the sine of the angle. Okay, so let's write that in. d2x is going to be d2, which was 2.2, times the cosine of 35 degrees, and that comes out to 1.80, and d2y is going to be 2.2 times the sine of 30 degrees, and that comes out to 1.26 kilometers. Now watch something here. This is important. Look at this. d1y was right here, and d2y is right there. And note that those are in opposite directions. d1y is north, and d2y is south. If those are in opposite directions, they have to have opposite signs. Look here, we said d1y was 2.9 or 2.19. The key thing here is that that number is positive. Back at the diagram, if this direction is positive, if north is positive, then that has to be negative. So let's take note, we're going to have to make this negative. This will be negative. If north is positive, then south has to be negative. And d2y here is south. Okay, that's not going to be an issue here with d3 because it is to the right. All of these are to the right, which we're calling positive, and this is up or north, which we're calling positive. So d3 here. d3 was, what was this, 4.3 kilometers, and the heading was 52 degrees. So think about this. If we have our north, south, east, west right here, then this is 52 degrees. Going from north all the way over to east, that's 90. That's a right angle. So if this is 52, then this has to be 38. Let's write that in. $38. So d3x is going to be d3 times the cosine of that angle, and d3y is going to be d3 times the sine of that angle. So let's write those in. d3x is 4.3 times the cosine of 38 degrees. That comes out to 3.39, and d3y is 4.3 times the sine of 38 degrees, and that comes out to 2.65. And those are both in kilometers. Now, look back at the diagram. What we're trying to find is this distance. That was our goal, the total distance from start to finish. What we're going to do is make a big right triangle. That, let me try again. Okay, that will be the hypotenuse. And we're going to have one leg here across the bottom, and then one leg here. Okay. Okay, well this leg across the bottom here is going to be the total eastward displacement. If you look at the diagram, watch this. Watch where I draw. This length, this total length, you should see will have to be d1x, okay, that, plus d2x plus d3x. Okay? Let me say that again. If you see this d1x and d2x and d3x, you should see that those have to add up to this total eastward displacement. So let's write this. The total eastward displacement is going to be those three pieces added together. So it's going to be 2.19 plus 1.80 plus 3.39, and that equals 7.38 kilometers. So let's write that in. 7.38. Now watch this. The vertical displacement, this piece over here, the total, that's not d3y. Okay, d3y is just this piece of it right there. We want the total right here. Okay, that's going to be, okay, watch my markings here. It's going to be this far north minus this far south plus this far north again. Again, think of up as positive and down as negative, or think of north as positive and south as negative. We go this far north, that far south, and then this far north. So it's going to be this distance minus that plus that. So let's come back over here. Okay, the total northward displacement is going to be 2.19, positive 2.19 minus the 1.26. That was that negative value we had, plus the 2.65. And that adds up to 3.58. And we're almost done. If this is 7.38 and this is 3.58, then we can use the Pythagorean theorem to find the hypotenuse. Let me just write this in. This is 3.58, and then we'll come back over here and do the final calculation. Okay, the distance from the starting point, what we're looking for, is just going to be the square root of this squared plus this squared. So 7.38 squared plus 3.58 squared. And we do that on the calculator, and it comes out to 8.20 kilometers.